So we're going to look at these two structures that aren't quite right formal charge-wise. This top one right here, if you're looking at that sulfur, we know, by the rules, it says that the +2 isn't going to work. But what we also know is that sulfur came with 6. It's in the same column as oxygen. It came with 6. And the oxygens came to this molecule with 6. So the formal charge is basically saying that it's less likely that the sulfur is going to just randomly lose 2 of those electrons. Because you see right now he's got 4 going on. So what's more likely is if we can get one of these oxygens right there, if we can get just one of the oxygens and one of these oxygens to become sulfurs, which is what they probably were to begin with, right? Because those electrons had to come from somewhere. If we could do something like that, then we'd know the sulfur and we could actually make those pink electrons attached to the sulfur. Well, then everything would be in a much better place. And it also makes sense because, like, if you count up the oxygens here, the oxygen electrons, the green ones, you've got the 1, 2, 3, 4, 5, 6, which is what they came with. So it makes sense that some of these electrons came from the sulfur. So what we're going to do is, why don't we bring them over here and just turn that into a bond? And now you can't do that with all elements because not everything can have more than 8 electrons, but sulfur can. Sulfur can definitely have more than 8 electrons. So if this becomes a bond here, and the other one is a bond, all of a sudden you can just really visually see that what's going on is that the sulfur, he's maintaining all the electrons he came with. So is each of the oxygens. They all have exactly what they came with. They each came with 6. So instead of the structure as drawn here, I have it redrawn on the bottom, what we really have, and I'm not losing electrons, I'm just putting them in different places, is this situation. And if you want to double check it, again, sulfur came with 6, and then you can see that it has a total of 1, 2, 3, 4, 5, 6 on it. So -6, and that gives us 0, which makes sulfur really happy. And then I'll do one of the oxygens. They're all identical, but you can see right now 1, 2, 3, 4, 5, 6. He came with 6. He has 6, so he's 0 also. You can't always fix it perfectly, but this is a good example of how paying attention to formal charge does show us that every one of the bonds in this structure are double bonds. We can check it experimentally. They're all double bonds. There is no resonance. Like we predicted resonance. There is actually no resonance as drawn for this structure. So, there's something to it, right? And we'll look at this one too. So I've gotten this one drawn. Now this one has 2 extra electrons from somewhere else. So some of these oxygens stole an electron from somewhere else. And it didn't come from any of the atoms in the molecule. So what we're going to try to do, though, is that sulfur came with 6, and you'll see that there's only 5 showing. So that means that one of the ones in one of the oxygens actually came from sulfur. So I'm just randomly picking one. I could pick any of them. But one of them came from the sulfur. And so to put it back on the sulfur for a better formal charge, we'll just make that into a double bond. And what that does to our formal charge right here is that our sulfur starts off at 6, right? Because that's what he came with. And then he's got 1, 2, 3, 4, 5, 6 electrons on him. So he becomes 0, and our formal charge becomes 0. And then same for this oxygen right here. It starts with 6, and I didn't put the coloring on one of the green ones, or I lost it somewhere. This was a green electron because it was attached to the oxygen. And so he starts with 6, and then you can see that there are 6 things attached to this one, and so that puts this at 0 also. So then your next question might be, but I didn't fix these 2. Well, sometimes you can't. If we were to take one of these and try to turn it into like a sulfur electron, what's going to happen is our sulfur will then have more than 6, and our sulfur will start become negative, and you don't want that. Once we get something, especially a central atom there to a positive, that's what you want. So you don't want to keep going once you get everything to 0. Also, it makes sense, like I said before, that we do have some that have a formal charge that's negative because they got electrons from somewhere else. You know, like maybe it was 2 sodiums that were nearby or something, and those 2 sodiums became positive and they got their electrons from there. And then, so I'm going to just redraw this. Remember this lone, I'm going to just grab that lone pair. It could be any lone pair, but I'm going to turn that lone pair into a double bond with, and there's my oxygen. So again, I didn't lose any electrons. I just moved them over and now some are sharing. And again, this gives us the situation we're looking for, and we get rid of the formal charge on one of them. Now that you're looking at this, you can see that this actually has resonance when originally we predicted it didn't. So these are 2 really great comparisons to see how formal charge changed the structure and helps us pick the right structure. It has resonance. So if you're wondering, well, how do I know if this does this or not, you know, where I can move these extra electrons around, pay attention to the central atom. If it's a 3rd row and up, or down, I guess, and down. And then also pay attention to these outside, like oxygen, sulfurs, especially those column elements. They can do this kind of stuff where they can move an electron around a bit.